suspending agents are also called as viscosity agent or the viscosity modifiers stabilize the solid drug particles and thus affects the drug absorption. Macromolecular gum forms unabsorbable complex with drug, for example, sodium CMC. Viscosity modifiers or imparters acts as a mechanical barrier to diffusion of drug from its dosage form and retard gastrointestinal transit of drug. Next factor is surfactants may enhance or retard drug absorption by interacting with drug or membrane or both. The surfactants have been considered as absorption enhancer again mostly in animals. Polyoxyethylene ethers have been shown to enhance gastric or the rectal absorption of lincomycin, penicillin, cephalosporin, and fosfomycin in rat and rabbits. However, in humans, oral polyoxyethylene 20-oleyl ether resulted in poor and variable insulin absorption. In general, anionic surfactants have little effect on membrane structure but cationic are not. Surfactants have been associated with reversible cell loss and loss of globate cells. The physiologic surfactants like bike salts promotes the absorption in case of glycofulvin, in case of like glycofulvin or steroids. It may decreases absorption when it forms the unabsorbable complex with other drugs above the CMC. Next factor is colorants. Even a low concentration of water-soluble dyes can have an inhibitory effect on dissolution rate of several crystalline drugs. For example, the dyes molecule get absorbed onto the crystal faces and inhibit the drug dissolution. For example, brilliant blue retards dissolution of sulfathiazole. By hearing this statement, we can uh, predict over here. The colorants are not only imparts the color, but these are also interferes with absorption of drugs. Next parameter is product age and storage condition. Product aging and improper storage condition adversely affect viability. For example, precipitation of drug in solution decreases rate of change in particle size of suspension, drug dissolution, and hardening of tablet and absorption. So this this was the formulation related factors, and next is next we will see about patient related factors. Again, patient related lots of factors are there which are directly or indirectly affect on the absorption of the drug. Among them, first is gastric emptying time or the gastric emptying process. Apart from the dissolution of drug and its permeation through the biological membrane, the passes from the stomach to small intestine called as gastric emptying can also be a rate limiting step in absorption because the major site of drug absorption is in intestine. As we know, the intestine is the major site of action for most of drugs. It is advisable where rapid onset of drug is desired for example sedatives. Drugs like sedative should be or having a desired or the desiration of rapid onset of action. Drug not stable in gastric fluid, for example penicillin, in that case faster gastric emptying should be there. Next is dissolution occurring in intestine, for example, anticoated tablets. So most of doses from having the dissolution process in a particular site of action like intestine or the particular site of GI tract. So here is the one diagram which is showing the different types of GI parts, and each part having a unique identity for the absorption. So we will start from mouth. The mouth having 6.8 pH, uh, and it having the small surface area, and uh, in that or in mouth lipophilic, neutral, and basic drug absorb directly in circulation. Uh, Second part is stomach, which having pH range of 1 to 3, and it is not too large surface area, but lipophilic, neutral, and acidic drug absorb in lesser extent as compared to small intestine. Next one is small intestine, which having pH range of 5 to 7.5, very large surface area. All type of drugs get absorbed, and it is also known as major site of drug absorption for most of drugs. Then next part is small intestine, which having pH range of 7.9 to 8, and uh, again it having the very small area as compared to small intestine. Then all type of drugs may be absorbed, but in a lesser extent. Last part of GI is rectum, which having pH range 7.5 to 8. It is again much smaller surface area, but here all type of drugs are absorbed. About half of the absorbed drug goes directly into the systemic circulation, like a mouth only. Then next part is the liver, which is the major site of drug metabolism. Then bile, bile having pH range of 7.8 to 8.6, and it aids absorption of lipophilic drugs, route for active secretion of polar drugs or the metabolites. Delay in the gastric emptying is recommended in particular where food promotes the dissolution and absorption. For example, grasopulvin, the drug dissolves slowly. Disintegration and dissolution of dosage form is promoted by gastric fluid. The gastric emptying is first order process. Several parameters used for quantify that, which are gastric emptying rate. Gastric emptying rate is defined as speed at which stomach extends empties into the intestine is called as gastric emptying rate. Next term is gastric emptying time, and in defined as the time required for gastric content to empty into small intestine is known as gastric emptying time. Next term is gastric emptying T half. So it is defined as time taken for half of the stomach content to empty. Next factors are factors influencing on gastric emptying. First factor is which affects on the gastric emptying is volume of meal. Larger the bulk of meals, longer the gastric emptying time, and initial rapid rate of the emptying observed with large volume of meal, and an initial lag phase is emptying of small volume of meal. Since gastric emptying is first order, a lot of volume of extent remaining in stomach versus time, and it yields as a straight line. Composition of meal, again composition of a meal matters in the gastric emptying time or the gastric emptying process. The carbohydrates, protein, or fats may be there. The delayed gastric emptying with fatty meal is beneficial for the absorption of poorly soluble drugs like grasopulvin. Next factor is physical state and viscosity of meal. Liquid meal take less than hour to empty, whereas a solid meal takes as long as 6 to 7 hours. Temperature, high or low temperature of ingested food reduces the gastric emptying. Next parameter, gastrointestinal pH. Again, the gastrointestinal pH matters with the absorption. Retarded at low stomach pH and promoted at high pH, the inhibitory effect of various acids on emptying decrease with the increase in the molecular weight order is hydrochloric acid, acetic acid, lactic acid, tartaric acid, citric acid. This is the order for absorption rate. Electrolytes and osmotic pH, water isotonic solution and of low salt concentration empty rapidly, whereas high electrolyte concentration decrease gastric emptying. Next is drug that retards gastric emptying includes poorly water soluble antacid, for example, aluminum hydroxide, anticholinergic drug, for example, atropine, narcotic analgesic, for example, morphine, tricyclic antidepressant, imipramine. Next parameter is disease state like gastroenteritis, gastric ulcer, pyloric stenosis, retard gastric emptying rate. Next parameter is intestinal transit like gastric emptying. The intestinal transit again matters great role in case of absorption process. Since small intestine is the major site of absorption of most drugs, long intestinal transit time is desirable for complete drug absorption. You can say over here the different parts of the intestine and their transit time. First one is duodenum, which shows the 5-minute transit time. Second one is jejunum, which having 2 hours transit time. Ileum, which shows 3 to 6 hour transit time. Cacuum, which shows 0.5 to 1 zero point 0.5 or half to 1 hour. Colon showing the 6 to 12 hours. Delayed transit time is desirable for drug that dissolve their dosage form, drug that dissolve only in intestine, drug absorb from specific site in the intestine, laxative promote the rate of intestinal transit, anticholinergic drugs retards gastric and intestinal transit, promote absorption of poorly soluble drugs, for example, propanthyline. Gastrointestinal pH. The gastrointestinal pH generally increases as one move down the stomach to the colon and rectum. Gastrointestinal pH influences absorption in several ways. For example, first one is disintegration. The if intercoated formulation is there, it gives the coat dissolves only in intestine followed by the disintegration. Dissolution. If weakly acidic drug is there, dissolve rapidly in alkaline pH of the intestine. If weakly basic is there, it dissolves in acidic pH of the stomach. Next parameter, absorption, depends on drug pK and whether it's an acidic or the basic drug. Gastrointestinal pH influences drug absorption by determining amount of drug that would exit in unionized form that at the site of absorption. Next is stability. Acidic stomach having the pH effect on degradation of penicillin G and erythromycin, but it can be overcome. This problem can be overcome by preparing prodrug of such drugs which having the lesser stability. For example, kirindacillin and erythromycin istolate. So we can avoid the instability problem by creating such drugs into the prodrug. Prodrug are the drugs which are upon metabolism shows the active moiety. Next parameter is presystemic metabolism. For a drug administration orally, the two main reasons for its decreased viability are increased absorption and pass metabolism. Okay, so in if we consider viability, so mm, on viable, bioavailability, mainly two factors are affect over there. First one is decrease absorption, second one is first pass metabolism. So decrease absorption or less absorption is directly proportional to the viability. If uh, absorption is decreases, then viability also decreases. And the first pass metabolism is increases, then viability is decreases. Means first pass metabolism is the inversely proportional with the viability. The loss of drug through the transformation by such eliminating organs during its passage to systemic circulation called as first pass or pre-systemic metabolism. The four primary systems which affect pre-systemic metabolism of drugs are: first one is luminal enzymes, second one is gut wall enzyme, third one is bacterial enzyme, fourth one is hepatic enzyme. As we know, our body is a rich microbial flora, so that's why many types of enzymes are there, and that enzyme also affects on the rate of absorption of drugs. We will see one by one. First one is luminal enzymes. These are present in gut fluids and includes enzyme from the intestinal and pancreatic secretions. Latter contain hydrolases, which hydrolase ester drugs. Chloramphenicol palmitate, which gives active chloramphenicol and which splits amide linkage and inactive proteins. After one approach to effect oral absorption of peptide is then to deliver them to the column which lacks the peptides. Next parameter is gut wall enzymes, also called as the mucosal enzymes present in the stomach, intestine, and colon. Alcohol dehydrogenase, which is the enzyme is present in stomach mucosa and it inactivates the ethanol. Intestinal mucosa contains both phase 1 and phase 2 enzymes. For example, sulfylation if ethylene estradiol. Colonic mucosa also contains both phase 1 and phase 2 enzymes. Next parameter is bacterial enzyme, which is also called as which is also called as microbial or the microbial source enzymes. The colonic or the colon generally rendered a drug more active or the toxic on biotransformation. In colon, it may be convertible into the more toxic or the active form. For example, sulfosalazine, which is used in case of the ulcerative colitis, and upon hydrolyzation process, it gives sulfopyridine and 5 uh, aminsa amine salicylic acid. Okay, enzymes hydrolyze conjugates of drug actively secreted via bile, such as glucuronide of digoxin and oral contraceptives. Next parameter is hepatic enzymes, also called as the liver enzymes. Several drugs undergo first-pass hepatic metabolism. They highly ex- extracted ones being the isoprenaline, propranolol, alpranolol, uh, pentoxyphylline, nitroglycerin, diltiazem, lidocaine, morphine, etc. These are the some names which having the or which are highly prone to the hepatic enzyme. Next parameter is gastrointestinal diseases. So again, different type of gastrointestinal or GI diseases also imparts onto the uh, absorption rate. First one is altered GI motility. The gastrointestinal disease and infection case, two of the intestinal disorders related with the malabsorption syndrome that influence drug availability. are celiac disease and Crohn's disease. Crohn's disease that can lead alter absorption pattern or altered gut wall, microbial flora, decreased gut surface area, and intestinal transit rate. GI infections like Shigellosis, gastroenteritis, cholera, and food poisoning also result in the malabsorption. Next one is gastrointestinal surgery. In case of gastrectomy, can result in the drug dumping into the intestine, osmotic diarrhea, and reduced intestinal transit time. In case of cardiovascular diseases, several changes associated with the congestive cardiac failure influences the viability of the drug. Next parameter is hepatic diseases or the liver related diseases. Disorder uh, uh, such as hepatic cirrhosis influence viability mainly of the drugs that undergo considerable fast pass hepatic metabolism, for example, propanol. Next one is gastrointestinal contents. A number of content can influence drug absorption as follows. Drug food interaction. If drug food interaction is there, then in the presence of different foods may either delay, reduce, increase, or may not affect drug absorption. So, depending upon the presence of drug and presence of food types, upon that it will be decided to it can it can delay the absorption process or reduce the absorption process or increase the absorption process or uh, it don't having any effect upon it or upon each other. Next one is fluid volume. Again, fluid volume also creates a major role or important role onto the drug absorption. If administration of drug with large fluid volume result in the better dissolution, rapid gastric emptying, and enhanced absorption. For example, erythromycin. Interaction of drug with normal constituents. The GIT contains a number of normal constituents such as mucin, bile salt, and enzymes which influence drug absorption. Mucin, a protective mucopolysaccharides that lines the GI mucosa, interacts with the streptomycin and certain quaternary ammonium compounds and retards their absorption. Next parameter is drug-drug interaction in the GIT. This interaction can be either physicochemical or physiological. So we can see first one is physicochemical interactions may be due to of adsorption, antidiarrheal preparation containing adsorbents like anti uh, ataplagite or kaolin pectin retards absorption of number of drugs co-administered with them. For example, promazine, linomycin. Next parameter is complexation. If unabsorbable complexes were formed, then uh, it will be very hard to make dissolve, and after dissolution, it will be very hard or toughest part to the absorption. For example, antacid or the mineral substances containing heavy metals such as the uh, aluminum, calcium, magnesium retards absorption of the tetracycline by forming unabsorbable complexes. Next parameter is physiological interactions are due to of decreased GI transit. Anticholinergics like propanthyline retards GI motility and promote absorption of drugs like ranitidine and digoxin and delay absorption of paracetamol and the methoxazole. Next parameter is increased gastric emptying. Uh, Metochlorobromide promotes GI motility and enhances the absorption of tetracycline and levodopa. So that's all for the day. So these are the different types of factors which affecting on the absorption process of the drug. So in next lecture we will see about the mechanism regarding the absorption process. Different types of mechanisms are there, and that each and every mechanism having some property in case of the absorption process. So thank you so much for being here and test